Welcome to Embedded. I am Alicia White. I am here with Christopher White. Today we're going to talk about machine learning and composting and the Jetson Nano. This will be an odd combo. And our guest is Shruthi Jaganathan.
Hi, Shruthi. Welcome.
Hi, thank you for having me.
Could you introduce yourself as though we met at a robotics competition?
Okay, so my name is Shruthi. I'm going to be a freshman at the University of Illinois Urbana-Champaign in the fall. So I've been interning at NVIDIA the past 2 summers, and I got involved because I did robotics at my high school. I worked on a lot of the software for a team, so that's how I found out about NVIDIA and worked here.
Okay, so just want to make sure that everybody got that you're just graduated from high school.
Yes, I just graduated in June.
And you did what kind of robotics?
So I did a program called FIRST Robotics. I've actually done multiple levels of it. So freshman and sophomore year, I did FIRST Tech Challenge, which is a small robot. It's about like 1.5 feet by 1.5 feet. And then in junior and senior year, I worked in FRC, which is FIRST Robotics Competition. Those are much bigger robots. So those are really cool to work with.
But those are fixed platforms. They don't have anything to do with NVIDIA, right?
No, actually. So our team and a lot of other FRC teams actually use the NVIDIA Jetson. So you can use it for anything from OpenCV, so that's like computer vision, to also just running neural networks on there, which is what we did one year.
And how did you fare in the competition?
Our team was kind of in the middle of the pack, but it was really cool to get to talk to a lot of the teams, which is what I think I enjoyed most. You learn a lot from the other teams and what they do and their approaches to solving the same competition problem.
I think we've talked to a couple other FIRST competitors in the past, and I don't remember neural networks and machine learning coming up much. Is that becoming more common in the competition, or was that something kind of new that your team did?
I think it's becoming more common now that a lot of teams have access to the Jetson, which I think really helped with like the internship here, because there was 12 of us, and so we were all from different teams. So we took back what we learned about the Jetson to our teams and got to use it. Like, I know my first year in FRC, that was right after the first summer we interned here. So we used everything we learned, and we created this neural network that would detect some of the game elements. And so it could have an auto drive for the robot to pick up one of the game elements in case our robot driver couldn't see it.
Which came first, your involvement with NVIDIA or FRC?
It was NVIDIA and FRC kind of at the same time, actually. I would do NVIDIA during the day, and then I would go back to school in the evening, work with our FRC team for summer training.
Okay, so you were an intern at NVIDIA, working all day at NVIDIA, and then doing robotics at night until you went back to school, and then robotics was part of school.
And then, robotics is just kind of a usual thing at school. I spend most of my time in that classroom.
And you are headed off to University of Illinois. What made you go there?
I think for me, it was the program that they have. So I'm going to major in a combined major called mathematics and computer science. So they're one of the few schools that I found when I was applying that had that major. So I thought it was really cool that I could kind of combine it, so I can also minor or major in something else without sticking to just math and CS, because I really wanted to be able to do both.
That's what I did. Good choice.
Okay, now for the most irritating question. What do you want to be when you grow up?
This is so hard every time someone asks me.
It's a terrible question.
It's a terrible question.
I know I want to do something like software related, and that's kind of it. Like, I don't have like a dream company that some people have. I'm just kind of open to it all. So I guess that's nice, because then I can end up where I end up going.
Yeah. I mean, you're going to college. Now you're going to start figuring out a lot more detail about what's out there. It's good to have an open mind at this point.
Yeah.
Okay. So the green machine, this is not part of FIRST Robotics. This is something else.
Yeah,
right?
This is separate. This is a project I worked on last summer at NVIDIA.
And what does it do and how does it work?
So it's, I think it's really cool personally, but I'm just saying that because I worked on it. What we did is we used the Jetson TX2 on a cart, like, you know, those carts that people use to like just transport things. We added a pole to it and put a Jetson TX2, a camera, and a projector on top of it and turned it into the green machine. So what it does is it runs a neural network that we trained and tested ourselves as interns. So it detects different kinds of waste and classifies it as either trash, reusable, recyclable, or compostable. And then it color codes these things on the cart for people to see. So it makes it really easy for people to like visualize what goes where. And it saves a lot of the problem of like people just throwing everything into the trash because it's easier than trying to figure out what you could recycle or compost.
So it sits at the end or on the way out of a cafeteria, and you put your tray down and it tells you, oh, this is compostable. Don't recycle your flatware, put it in the compost bin, and this is a bottle. So this is definitely recyclable. That sort of thing?
Yeah, exactly. That's the same kind of thing. Yeah.
And it has a screen. So it takes pictures, and then puts on the screen color coded what goes where.
So there's a version of it that you could run on a screen if you don't have a projector. So that's what we originally tested on because we didn't have like our full setup yet. So you can run it like on a computer and you just show the camera whatever's on your tray and it'll pop up on a computer screen. But the final version of it is it's like a life-size demo almost. So you can look directly at your tray. You'll see the boxes and the colors projected onto your items. So if I had like a bottle on there that was recyclable, I would literally see a blue box around that bottle.
This is like augmented reality.
Yeah,
sort of.
Almost. That was kind of what we wanted to go for.
Okay, and it identifies things with machine learning? I mean, did you take like 1 billion pictures of trash and hand code them?
Not 1 billion, but I mean, it was like
felt like
over
that.
5,000. It felt like that at times, honestly. We would sit there and like draw boxes around each thing and label each thing like every day for hours. And we would get so tired. But honestly, it was worth it because like that's one of the most precise neural networks I think I've ever made.
Why couldn't you just use pictures from the internet, from one of the data stores?
So we kind of looked into that, but we also thought we didn't really find something that we thought would work for us. And we also thought since we were working in this cafeteria, like we could find a lot of things that, you know, you might not be able to find elsewhere because some places have like utensils that might just be reusable. But here there's like compostable ones and there's reusable ones. So there's some things like you have to be able to tell the difference. Like, yeah, they're both utensils, but they're different kinds of utensils. So we thought that problem would best be fixed if we could take the pictures ourselves and label them ourselves.
And does it work? I mean, does it really work or does it just kind of work?
It actually works. Like we actually had it in the cafeteria for people to use by the end of our internship.
And that was last year?
Last summer, yeah.
Are you working on it this summer?
No, but I did work on it a little bit, trying to transfer it over to the Jetson Nano. So it's not like a full-on internship like last year, but I am trying to get it ported to the Jetson Nano so that it's like a more compact version than trying to stick a TX2 on this cart.
And which parts did you particularly work on? I mean, there's maybe actually before I ask that, I should ask for kind of a block diagram of the system.
Okay.
Input comes from a camera.
Yeah. So there's a camera that looks at what you have on your tray. And then it sends that to our TX2, where we run it through our neural network. So it classifies each thing. So what we did is we had multiple classes. So we had like utensils, we had like plates and bowls, we had chip bags, wrappers, stuff like that. So the neural network classifies it into that. Then we send it into our script that we wrote that classifies it from these, like, I think we had 9 or 10 classes, and then it separates them into recycle, compost, trash, or reusable. So that's like the final step. And then it would draw those color-coded boxes directly onto the tray.
Through the projector?
Through the projector, yeah.
Is the projector HDMI? Is it basically just a screen out?
So it was connected to the Jetson as well. And like there's obviously a power source for it. So it has to be plugged into a wall somewhere. And we just used our like calibration script to align the projector to exactly what the camera sees. That way, when it draws the boxes, it's actually aligned.
And you mentioned OpenCV earlier, so that makes a lot of sense. What else are you using as far as libraries go?
So we use TensorFlow to train our networks. The camera we used was a CSI camera. That was so we could reduce latency because we originally tried like a regular webcam, but it was just too slow. And we really wanted something that would work on the spot. So people are not just like standing there waiting for it to draw the boxes. Those were the two biggest things. Obviously, we had the Jetson TX2 as well.
And you said you determine its utensils and then you determine whether it's recyclable or one of your categories.
Yes.
Why do you do the intermediate step?
So that kind of helps if, the things that we're trying to find ever change. It also helps for more accuracy of the network. So for example, there's lots of things that you could consider compostable. Like there were compostable bowls, there were compostable like forks and spoons. And when you try to classify them all as one class, it becomes really hard to get an accurate network because there's no certain thing that it can kind of latch on. There's no like shape or color or anything that it can use to classify these as separate things. So then it becomes like 5,000, 6,000 images. It won't be enough at all, which is why we thought it might be better to classify them as their own kind of thing first, like separate utensils versus bowls. But then we would use our own script to combine them later to call them all compostable.
And the TensorFlow, did you use Keras as well or just TensorFlow?
We just used TensorFlow. They had, we used SSD MobileNet. We trained off of their base network because they had a lot of data in there already, which kind of helped speed our process along as well instead of training from scratch.
Yeah, that makes sense. But you're identifying multiple things in the picture. That's a harder problem than just identifying what the whole picture is. How do you do that?
So what TensorFlow kind of made it easy to do is we had, it let us do multi-class detection. So you had an option to put in as many classes as you want. And so we would train for all these 9 or 10 classes that we had. So TensorFlow really gave us a good starting point for already having multi-class detection. But the harder part became when we started adding images from all of these classes. And then it would start to get kind of confused. Sometimes like it would see white and be confused, like, is this a bowl or a fork? And then that's when we started taking notes about which classes it was confused on. And so we would take a lot more pictures of those things and add it into our network.
But it's simultaneous multi-class detection, or do you only show it parts of the frame at a time?
It's simultaneous. It sees the entire picture and detects whatever's in there. And
TensorFlow has tools for that?
So we use TensorRT as well, and I think that kind of helped it.
Yeah, that's NVIDIA's underlayer that helps.
Yeah, that really helped with the multi-class detection like afterwards. So TensorFlow helped with the training and TensorRT helped with like the actual testing.
So what part of the project did you think would be challenging but turned out to be straightforward?
I really thought the multi-class detection would be the hardest because the previous year I was trying to work on some multi-class detection. It was only 2 classes, but it took forever to get it working. So I thought that would be the worst, but I think TensorFlow really helped me in that because I worked a lot on the network in my team. And so TensorFlow made it easier to get it detecting those multiple classes. Of course, it was kind of frustrating when it would detect 2 random things as the same thing, but it was a process and adding a lot more images really helped make it better.
Did you use a convolutional neural network? Those are usually what you use with computer vision.
Yeah, that's what we used.
And then other than getting the right data, was there anything that took longer than you expected?
I think that was the biggest thing. Another thing that took a little bit longer was our calibration. So So I think I mentioned it earlier. We had to have the projector the same way, looking at the same thing the camera was looking at. So we had to create our own calibration script, which one of our teammates did, which I thought was pretty cool. He added QR codes to like the four corners of the screen that the camera sees. The projector looks and scans for those QR codes, so it can set up like a border. And it also like helped us so we could draw out a border for people to place their tray in directly. So it not only helped like the projector, it also kind of guides people where to place their things so we can actually tell them what we're looking at.
A lot of people find the whole machine learning thing a little difficult to approach. I know I have a few times. How did you learn all this?
I think for me, like, honestly, I found it really scary too. I didn't really know what I was doing. But for me, the hands-on approach was the biggest thing. Like, I've read articles about machine learning coming in, but for me, it was just like getting into the project and like doing a lot of research every time I would find like a problem or we'd run into an error. So like just doing the research along the way, I think that was for me the biggest thing. And I feel like that could really help a lot of people as well. Like it's kind of hard to get started, but once you do, you just have to keep trying.
So do you worry about gradient descent and the integration ability of the terms you're using, or do you just throw things at it and if it works, it works?
So you're talking about our green machine network?
Yeah.
So that's kind of cured by when we're using TensorFlow in a way. So we didn't really have to worry about it when we were training our network.
Yeah, there's a lot of difficulty with really understanding how it works as if you were going to build it versus just using the tools out there. And using the tools seems to have worked pretty well for you.
Yeah, I think for us that really helped because I think a lot of it that goes into it is like there's a lot of math problems that goes into it, and that's kind of hard to understand at like a high school level. So it's nice that we have so many resources that we're able to use.
So have you taken calculus?
Yeah, I took calculus in high school.
Oh, I mean, I would assume so, but my calculus went to derivatives, so I was thoroughly confused by the giant S symbol.
Oh, yeah. It took a while to get. There's a lot of Khan Academy videos and stuff I watched on the side. So
a hands-on approach is you did this through the Jetson TX2 and working with NVIDIA.
Yeah.
That was your method to a hands-on approach.
Yeah, that was my just getting into that project and trying to figure it out no matter where I got stuck. That really worked for me.
And did you do the 2 days to a demo, or was there something else that got you started?
I did 2 days to a demo. That was like the first thing all of us interns did on the first week. We didn't do anything until after 2 days to a demo. So I think that was like a good head start on how to start working with the TX2 as well as the Nano, I guess, because you can use it for both.
So for people who don't know, will you describe the 2 days to a demo and what you do?
Yeah, so it's kind of like a guide to deep learning, I would say. It gets you started all the way from first just kind of getting your Jetson set up. Then it teaches you how to inference using the previously made scripts, and it leads you to even trying to create your own network and running that on the Jetson. So it takes you a step-by-step process.
One of the things I like when I first got my Jetson was running their mobile net and having it recognize things. There was just something magic about putting things in front of the camera and watching it do very well or very badly.
Yeah, I think that was really fun too. I just kind of would hold up whatever I find at my desk and see what it says. I thought that was really cool.
I found it hilarious that one of my puppets, which is a frog, a tree frog, it actually got tree frog. And it was really great.
Uh-huh.
So going back to EnviroNet, is it in the cafeteria now, or is it a prototype that's been used in the lab and does it reside in the cafeteria?
So we're still working on getting it into the cafeteria, but we have tested it in there.
And who's going to work on it next? Are there new interns?
So it's still kind of us. So the project was in a completed stage, but what we're working on now is kind of getting it ported to the Jetson Nano to make it easier to use almost because, the Jetson Nano is much smaller than the TX2. It makes it more portable and also kind of safer than the setup we have right now.
Were you using the big dev kit for the TX2?
Yeah, we were using the TX2 dev kit on there.
Okay, so tell me about the Nano. I don't have one of those.
So the Nano I like to think of it, it's like a really small, powerful computer. And the cool thing about it lets you run multiple neural networks in parallel. So it's really useful for things like image classification, object detection, stuff like that. And for me, the biggest thing, it was really easy to set up. So I was trying it out this summer as well. It's like it comes in a really easy to use package. It's like one thing and the whole thing starts running. So it kind of makes it also easier to use for people who've never done AI before. It's really approachable, I think. And also the fact that it is small kind of helps because you can use it on a lot more projects.
Okay, so there's a dev kit and there's the module. How big is the dev kit? It's not as big as the whole TX2.
Yeah, it's not big as the whole TX2. The exact size, it's 79 millimeters by 100 millimeters. In inches, it's 30 inches about 30 inches by 4 inches.
3 inches.
Three, sorry, not 30. My bad.
It's a credit card size.
I don't know why I said 30.
Yeah, that's pretty small.
Is that the module or is that the whole dev kit?
That's the whole dev kit.
Wow.
Yeah, it's really small.
It's called the Nano. It can't be big.
I know, but is it comparable with respect to computational power of the Jetson TX2?
I think it's like more of an entry-level product. So it's like for people, who've never done AI before, it's nice to get started with. But computational power-wise, it would probably be like the TX2 would be after, and then the Xavier is obviously has the most computational power.
I don't know if this is right, and I don't know if you're the right person to ask, but I think of the TX2 as like 4 Raspberry Pis squashed together, Raspberry Pi 3s, with a better GPU. And then
way better GPU.
And I think of the Xavier as kind of 2 TX2s squashed together. And so it sounds like the Nano is maybe a half a TX2, a 3/4 of a TX2.
Yeah, that sounds about right.
Okay. And so as you're trying to port it, are you running out of space?
Not at all, actually. So we have like an SD card in there that also increases its storage. It's also what I use to get Jetpack on the Nano in the first place. So storage wasn't really an issue at all when I was trying to port it over.
What about computational power?
No, honestly, it worked to me. It felt like it was working the same. It was really easy to use.
Okay, why aren't you done yet then?
Wow.
That's a hard question. Actually, I think so we're just trying to make it even better, I think. So that's kind of it. So there was one change, though, porting it from the TX2 to the Nano. It's just the way that we use the camera because there's a new thing that NVIDIA has released called JetCam, which is more compatible with the Nano, I think, than what we were using before. So that's kind of the only thing that we really have to change, which we're working on to get that fully up and running so we can actually put this in the cafeteria.
And is that hardware or software to work with the camera?
It's software to work with the camera.
What does it do?
So what it helps us do is kind of interact with the camera. So that's what we use to get the image that the camera is looking at. And we take the image from there and port it into our script. So that's where we run the actual inference on the image.
So it kind of replaces OpenCV?
In a way, yes. I think you could say that, yeah, it replaces OpenCV.
I work with a TX2 and I use GStreamer because OpenCV is too slow, and GStreamer is this massive, you can do anything with it as long as you know the right magical incantation, and it really is a magical incantation that is hard to figure out. Have you ever seen that? Have you ever seen GStreamer, or has it mostly been OpenCV for you?
I've seen GStreamer. I mean, I personally haven't used it because it's come kind of in the package for me. But yeah, I've definitely used it for inference, and JetCam uses that as well.
Okay. So I shouldn't run out and get JetCam right away if my GStreamer's already working.
But I maybe think I'll JetCam makes it easy to interact with the camera. That's my favorite thing about it. Like you don't have to go into the camera and try to figure it out. JetCam has methods already set up for you.
That's good.
Yeah.
Did you have any particular challenges moving the green machine from TX2 to Nano? It sounds like no, but
it was really the changing the camera. There was no other challenge with it at all. I'd say it was very easy to switch it over.
The green machine, did you come up with that idea as a group, or was that something NVIDIA had in mind when you got there?
So the original idea, that our group started with, we just wanted a way for people to figure out how to throw away their trash properly. And then it transformed into this idea where we started with the screen, and then we were like, oh, why not make it AR? So we talked to people at NVIDIA who helped us make that a reality. And of course, changing it to AR kind of came with its own challenges, but it was kind of cool to start with that small idea, and then we made it our own.
And did you learn anything about recycling and waste systems as you went through this?
I mean, I definitely learned what's compostable and recyclable. Before I was kind of reading the labels and I was iffy about where things go. But now I know oh, this is a compostable box and this is a recyclable bottle. So, it helps me throw away my waste properly too.
Do you have any intuition what features it's, maybe not, but what features the network is looking for did you have to distinguish between this is a compostable fork and this is not a compostable fork?
Yeah, she said she did.
She said, yeah. I thought you said that. So do you have any sense of what it was detecting to make that different distinction?
I think part of it was the shape, because the shape of the compostable fork versus the reusable fork was actually kind of different. What in our training data.
Okay.
And I'm sure color kind of helped a bit because the reusable ones were silver and compostable ones were more white. And we trained those two networks, those two classes separately. So we had a class for compostable utensils and we had a class for reusable utensils, which definitely those two were one of the hardest ones to train because, it's looking for geometry, and forks are always going to be forks. So probably we had the most images of trying to help the network distinguish between the two.
Did you have any debugging tools to figure out if it was choosing some feature that you needed to talk it out of?
I think a lot of it was just we kept on testing it in different environments. And as soon as we would see that something was getting confused, we would make a note of it and go back to our images, see if we had mislabeled something sometimes, or if it wasn't that, we would just add a bunch more images about each of those classes so that it would help the confusion a bit.
So I think you mentioned you used 5,000 or so training images.
Yeah.
That seems really low.
Doesn't it?
What I haven't done this as much as Alicia has, or even at all. I've just learned by osmosis, but I'm used to hearing about hundreds of thousands or millions. That makes me happy to hear this works with so few. Is there a reason that was doable with so few images? Is it just because you're looking for very specific things, or?
If you ask me, 5,000 is a lot because I labeled all of them.
You have to do them by hand, yeah.
For us, we also use augmented images in TensorFlow. We had an option to add that, and we did a bunch of augmentation ourselves. So of course we took 5,000 pictures, but in the network it would train with not only those 5,000, but the augmented images as well. Especially when we added the projector and the colored boxes of the projector. It would get super confused because now all of a sudden you have this bright light added to your items and it's oh, am I really looking at a bowl or is this something else? So augmented images really, really helped our training.
And so augmented images are things like when you have a picture, you flip it left, right, and up, down. And so now you have 4 images instead of 1.
Yeah, exactly.
What other augmentations did you do?
So we wrote a script to add different backgrounds and different colors near the objects. So that kind of helped with the colored boxes from the projector issue. We did definitely the rotating and the flipping stuff as well.
And you mentioned, so you have the projector and it's pretty bright. And so initially I would walk up to the machine, I would put my tray down and it would be white light, right?
So there's no light coming out of the projector at all when you like put the tray down.
Okay. So then it takes some pictures and it runs those through its neural net and it comes up with an answer. And then I have a blue box here and a green box there. Does it then try to take those images and say whatever's a green box is now in this class that reinforces the green boxness?
Oh, so yeah. Originally, that was part of the problem, like the colored boxes. But it wasn't running like exactly the same time. Like it was a live action thing, but it was running at 15 frames per second. So that little bit of change, so the colored boxes didn't affect it as much.
Okay. So you tried to make it so that the color didn't lead it. It's kind of like leading the witness in legal terms. Yeah,
we tried to make sure the color wouldn't affect it.
See, I would have done something crazy, like, and probably ill-advised, like try to inner strobe the camera and the projector, so it was never seeing it when it was lit, but it looked like it was always lit to the human. That wouldn't have worked.
Either that or augment the images so that you get one that looks like it's got green on top of it all the time and one that looks blue all the time so that it wouldn't learn the colors. But then you can't learn any colors. You'd have to use grayscale all the time. Yeah. Did you use color or grayscale?
We had colored images in our data set. They were all colored.
Did you ever consider using grayscale?
We thought about it, but like really for us, I think color was important because it was kind of distinguishing, like I brought up earlier with the utensils, like it did play a factor in that. So for us, color was pretty important. So that's why we left it.
And recycling rules change. They have changed a lot in the last few years with respect to plastics. Would you have to start over with training images, or can you do something with the output or your intermediate steps?
So the nice thing about the network is because the network doesn't classify whether it's recycle or waste or anything. All we'd have to do is go back and change our final script that categorizes each of the classes. So for example, if like that fork became recyclable, all we'd have to do is go into our script and change that so that it would draw a blue box instead of whatever other color.
And the scripts, is it Python?
Yeah, it's a Python script.
Did you ever consider monitoring what receptacle the person put the trash in so that you could set off an alarm if they did the wrong thing?
Sometimes when we would stand like in the cafeteria and ask people to take pictures, we would see like people dumping everything in trash and we'd be like, oh no, like, but we never thought about setting off alarms or anything.
Maybe blind them with the projector.
Oh my God.
Sorry.
Christopher's figuring out how to punish the rule breakers.
You could mark the rule breakers with the projector. You could
give them little red hats.
Yeah, and then everyone could point and laugh.
That sounds so mean.
I'm sorry.
Back to your neural nets and the 5,000 images. Was this built upon the mobile net network already? I mean, did you do the transfer learning thing, or did you learn just from those 5,000 images?
So it was built off of that mobile net. It's called SSD mobile net, and it was trained off of the COCO data set. So it has like a ton of images of a lot of like real world things. So of course it had images of things that we were also training off of. So that was nice because it helped our network have somewhere to start.
And so if I put my frog puppet under it, would it call it a tree frog? And then would it tell me to compost it?
Probably not, because that's not one of the things it's trained off of.
What does it do when it gets to an object it's never seen before?
It just doesn't draw anything around it. It won't recognize it, so it won't classify it. It'll just be like, there's no color on it at all.
And what does it do internally? Does it have a log? Does it tell you, I didn't get this, you should take a picture and train me later on what I should do about it?
No, we never added anything like that to our project. So it was mostly like us looking at it and seeing if it ever classified something wrong or if it was mixing something up. So it was just kind of our team working on it.
Okay, so back to the Nano. You are trying to move the green machine to the Nano, and it sounds like you're having a bit of feature creep trying to make it better. When do you throw in the towel and say, bye-bye, I'm off to college?
I leave in August, so I still have another month to get this working. But I mean, I've been working on it all summer, so I've had the chance to get it running, and I think it's doing pretty well so far.
Are you going to have another demo?
I don't know, but that would be pretty cool.
And do you put the code online? Do you make it open source, or is it not?
Yeah, it's all on the GitHub. So if you just like search up NVIDIA Green Machine, you'll find our entire GitHub project.
Do you put your models up as well?
Yeah, we have just our final model, which is like the best one that we picked. That's also on GitHub. So if anyone wants to like recreate our project, they have all the resources to do that.
Were you nervous putting it online? I mean, everybody can see your code and criticize it.
I mean, for us, I feel like not really, because we were proud of like the version of the project that we put up. Like we had time to get it working, and the cool thing was like we had so many working networks. Like we also got to pick which one we wanted to put up online for everyone to see. So having that choice was nice. Like we have working like versions of it, so it wasn't as scary as like it sounds.
Okay, I mean that's really good. Has anyone forked the repository so that maybe somebody else is building this, or is it still just you?
I think a couple people actually have. Like we've gotten a few emails about people like doing the project, asking questions. So that's kind of cool actually to see like people are actually trying out this project, and it's nice because it's like something we started and people are using it.
It's always a great feeling. Do you think you will continue with things like this? I mean, if NVIDIA says next summer, come back and redo it, or come back and make it better, is that interesting to you, or are you done with this and ready to try something else?
I mean, it would be fun because I really like working with AI. It's just kind of cool for me, especially working with the networks. That's what I do a lot of my work on, because it's like you're teaching a computer to learn like from nothing to all of a sudden it's recognizing all these things. So if they called me back, I think I'd be pretty happy to come back and work on that.
As you were applying to colleges, did you talk about the green machine much?
I actually did. I brought it up in some of my essays. So that was pretty cool. Like I had a project I was proud of to talk about.
It's really nice when we talk to people graduating from college and wanting jobs. Having a portfolio is always something that's pretty cool, because it means during an interview, you're talking about something you know instead of being asked questions you don't know.
Mm-hmm.
And so you've already got part of your portfolio. Are you, going to blow off school entirely and just go get a job? I mean, you're in Silicon Valley.
Yeah, she sounds like the sort of person who would do that.
Probably not. I'm not that much of a risk taker. So, still going to college.
Embedded, sued by Shruthi's parents. All right. I've already asked you what you want to be when you grow up. And that's a terrible question. It's in my outline, but it's in my outline for everyone, not just you, although usually we don't ask
Even people who are theoretically grown up.
I am so not a grown up. Don't even. But how do you decide computers? Do you ever think, I would rather do art, or I would rather write, or...
I think that all the time.
Music for you.
Like, if I'm being completely honest, like until high school, I wanted to be a psych major and like become a doctor or something. And then I started doing robotics and I was like, wait, this is really cool. I kind of want to do this now. And I think the NVIDIA internship was kind of cool because that was like, I realized, oh, wow, this is actually a job that I could see myself doing a few years in the future. So Like, yeah, I had other thoughts before, but like high school kind of solidified it for me. Like, I really do want to do computer science.
Well, if you think about it, you are a psych major.
I
mean, you're just hand tuning a little brain.
I guess if you think of it like that, like, you know, I'm already majoring in something, so that's pretty cool.
I minored in cognitive psychology and theories of learning, and it isn't directly transferable to neural nets, but sometimes I'm like, yeah, okay, I kind of remember this from psych. So you don't have to give up. I mean, you can do both.
Yeah, if I really want to, yeah.
Well, and you should always take humanities. It helps you connect to people.
Mm-hmm.
Have you worked with other hardware? I mean, you mentioned FIRST, but have you worked with other microcontroller platforms?
I've done a little bit of work like with the Raspberry Pi, but I think my biggest like experiences come from FIRST NVIDIA, like working with the Jetson.
Do you think you'll continue to do that sort of thing in college? Do you know already if you're going to be part of the robotics club or you're going to take an awesome class in computer vision when you get there?
I really want to. I haven't decided yet. Like, I also want to be able to try other things. Like, I know I want to like try out for an a cappella group in college. So stuff like that. Like, maybe I will join the robotics team, but I'm just kind of leaving it open to me figuring it out when I get there.
I think that's awesome. I think that's completely awesome because, yeah, so much changed going from high school to college that if I'd made any plans, they would have just been dust.
And there's like so many options too, which is really cool.
Well, and Urbana-Champaign, it will be nice for a few more months.
Mm-hmm, yeah.
And then you'll study all the time because you can't go outside.
Exactly.
Are you really sure about going to Illinois? I mean,
I really like I don't know.
Not the time to talk. This is you can't. What are you doing?
I'm trying to get her to go to Stanford.
It's too late.
I don't know. For me, like weather was never a factor in like my college thing. I was like, I will get used to the cold weather if that means I go to one of like the programs I really like. So that's why like it was just a program for me.
So I didn't do an internship until junior year of college. Yeah, summer between junior and senior year of college. I can't imagine what it would have been like doing it in high school. Do you have any advice or things you kind of took away from jumping straight into kind of working at a company?
I think the thing like for me was it's like a really good experience because you learn a lot and it's like a chance to work in the industry and there's not like a lot writing on it. Like if you mess up, no one's going to get really mad at you because you're a high schooler. So like it gives you that room to figure out what you want and figure out like how to solve this problem in the best way with like a little bit of room to mess up. So it felt more relaxed. Like it wasn't a high pressure thing. So I would say like if you're in high school and you get into an internship, like just do it. And it's not the end of the world if like your project isn't the best thing at the end. Like it's an opportunity to learn.
How did you get into NVIDIA as an intern in high school? I mean, there are people who would be very excited to be interns after college. How did you swing this?
So it was through like the FIRST Robotics program. They work with NVIDIA pretty closely. So NVIDIA gave us like an opportunity to interview if like through the FIRST program for the internship. And then through all those interviews, they just selected a group of high schoolers to come in.
That's pretty cool.
Yeah.
All right. I know you have things to do and we have otters to see. Do you have any thoughts you'd like to leave us with?
For anyone listening, I just gotta say, like, get involved, like, do things you're excited about, and don't be afraid to try something new.
That is always good advice. Our guest has been Shruthi Jaganathan, soon to be freshman at University of Illinois Urbana-Champaign, and graduated senior of Cupertino High School.
Thanks, Shruthi.
Thank you for having me.
Thank you to Christopher for producing and co-hosting. Thank you to Tom and Jakey Poo. Really, you're going to make me say that. To Jakey Poo for questions. And thank you to our Patreon supporters for Shruthi's mic. And of course, thank you for listening. We are having a party. It is September 7th in Aptos, California. Invitations or Eventbrite or whatever it's called goes out on August 1st. You can always contact us at show@embedded.fm or hit the contact link on Embedded FM. And now a quote to leave you with. Memories are not recycled like atoms and particles in quantum physics. They can be lost forever. That actually comes from Lady Gaga. I was kind of surprised. It's pretty cool though. Embedded is an independently produced radio show that focuses on the many aspects of engineering. It is a production of Logical Elegance, an embedded software consulting company in California. If there are advertisements in the show, we did not put them there and do not receive money from them. At this time, our sponsors are Logical Elegance and listeners like you.